Hey folks, this is a video going through the Module 11 Part 2 review. Couple of things. Make sure that you clean up all your answers. Remember what that means? Basically just like no roots on the bottom, no negatives on the bottom. So we got to do that little cleanup portion in there. All right, so there's a couple of sections. We're going to start off with the first section. The second section is like the first section. You're just looking for the angle. We're up here. They tell us the angle. So if you remember sine of negative 2 pi over 3, I first have to figure out where negative 2 pi over 3 is. Pi over 3 is 60. This means I'm counting two 60s backwards. So I would go 1, I would go 2. Then I draw my triangle 1 to the origin, 1 to the x-axis. And I take that triangle and I blow it up. Make sure it's oriented correctly. And then I fill in the details. This is a right angle. We counted by 60, so that's a 60. Opposite the 60. Now, you don't have to have this memorized. What you can do is you can look this up on your unit circle. So, like when I counted by pi over 3s, if you don't remember that that's 60, I go here to pi over 3 and 60 are the same thing. So I counted by 60, I went -1, I went -2 gaps of 60. Then, as I fill in the triangle, I'm filling in the 60 triangle. So opposite 60 is square root 3 over 2, adjacent is 1/2. So my triangle opposite 60 is square root 3 over 2, adjacent is 1/2. Now, the last question you always have to ask yourself, are there any negatives? So that's 0, 0, where the reference angle is, and we went to the left, so that must be negative, and we went downward, so that they're both going to end up being negative. Now I actually answer the question. I go back here, it says sine. Sine is the same as the opposite over the hypotenuse, or just in the unit circle, the y side. So this is the y side because it goes up and down. So my answer would be the negative square root 3 over 2. Now, as I do this video, I really recommend you pause after each one and try to do the problem on your own and then watch the video if you can. There's an answer key in Classroom. So if you're just checking your answers, you can use that. But I recommend trying to do this on your own and then coming back together and seeing how we did. All right, so again, pause it, try it on your own. So I did pi over 3, that's 60. This means I'm counting 14 gaps of 60. This time I'm going the positive direction, which is up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1 to the origin, 1 to the x-axis. That triangle is too small to work with, so I'm going to take it, I'm going to blow it up. Highlight the right angle. The reference angle is 60 degrees, so I'm going to use the same triangle that I just did up above. Opposite the 60 is square root 3 over 2. Adjacent to the 60 is 1/2. Any negatives, that's 0, 0, so I went backwards, but this time I went up, so that side would stay positive. Now it's time to answer the question. The question was, what is the cosine side? Cosine is the same as x in the unit circles, the one that goes left and right, so my answer would be -1/2. Tangent, 7 pi over 2. Again, I'm going to start off by drawing. I encourage you to pause first. Pi over 2, I would look at my unit circle. Pi over 2 is the same as 90. So that means I'm counting 7 gaps of 90 in the positive direction. So that would be 1, 2, 3, 4, 5, 6. This is the one that we want, 7. Now, since I can't draw a triangle here, if I go to that same location on my unit circle, we don't have a triangle, we have a point, 0, -1. Okay, so now we're going to evaluate what is tangent at this spot. We're trying to figure out tangent, and tangent, looking back, tangent sine over cosine, tangent is the y side over the x side. So y over x. So in this problem, the y coordinate is -1. The x coordinate is 0. -1 over 0 is no way. The 0 is on the bottom. That is not good. So we would write undefined here. Cosecant of 11 pi over 4. Figure out where I live first. Counting by pi over 4s, those are 45s, 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 to the origin, 1 to the x-axis. Take that triangle and blow it up. Right angle, we counted by 45s. So now I'm going to use the 45 triangle. Look over here, my 45 triangle has an opposite of square root 2 over 2 and an adjacent of square root 2 over 2. Always ask, are there any negatives? So I would take this, negative would be here, positive would be there. Okay, so now we're going to figure out the cosecant is what we're looking for. The cosecant, nobody ever gets cosecant. They look back and they figure out who is cosecant. It's one of the reciprocal trigs. So if I look at cosecant, it's the reciprocal of sine. So what I'm going to do is I'm going to take the sine side, which is the y side, and I'm going to take that answer and flip it over. So cosecant is the reciprocal of sine. So the sine side is the y side, the one that goes up and down. I'm going to take that fraction and flip it over. This answer is not okay because there's a square root on the bottom, so we would multiply by root 2 over root 2. On the top, 2 times root 2, we can't make that look any nicer, so that's 2 root 2. But on the bottom, root 2 times root 2 is root 4. The root of 4 ends up being just 2. Now, a lot of kids want to cancel out the 2's here. That is not true. The root part cancels out, not the number. But in this next step, they actually will cancel out because you got a 2 divided by a 2. So my answer would be square root of 2. All right, let's figure out where we live. Pi over 6, that's 30. 19 of them backwards. So that's -1, -2, -3, -4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 1 to the origin, 1 to the x-axis. Take that triangle and blow it up. Right angle. Reference angle, we counted by 30 degrees. So opposite the 30, again, I'm going back to these triangles. Opposite the 30 is 1/2, adjacent is square root. So this would be 1/2. This would be square root 3 over 2. But the thing that our unit circle doesn't tell us is the sign of these. So you got to be careful. This is my origin. I went backwards and then I went up. So it's negative there. Okay, we're trying to answer the question. Secant. Secant is the reciprocal of, I go back to look at my sheet. Secant is the reciprocal of cosine. So I'm going to take the cosine side of this triangle. I'm going to flip it over. Cosine is x, so it's this side. I'm going to flip it over. Now, when you take a negative and flip it over, it's still negative. Positive flipped over is still positive. When the reciprocal something, it keeps its sign. But this is unacceptable at the Algebra 2 level, so we would now clean this up. -2 root 3 over 3. This time, nothing cancels. The one up above, I had 2 over 2. This time I had 2 over 3, so -2 square roots of 3 over 3. Cotangent of -5 pi over 6, I'm counting by 30. I'm counting 5 of them. I'm counting them backwards. So 1, 2, 3, 4, 5. 1 to the origin, 1 to the x-axis. Now I'm going to take that triangle. I'm going to blow it up. This is a 30. This is 1/2. This is square root 3 over 2. Backwards, so negative. Downwards, so negative. They're both negative. Okay, we're doing cotangent. Now, cotangent's a little tricky, but remember, these are reciprocals. So cotangent is the reciprocal of tangent. When I go over here and look at tangent, tangent is y divided by x. So if I'm doing the reciprocal of that, that must mean cotangent is x divided by y. So I'm going to take the x side of this, and I'm going to divide it by the y side. So that would be negative square root 3 over 2 over negative 1/2. I took the x side, I divided by the y. Nobody can divide fractions, so what we do instead is we flip and multiply. So I leave the top the same, I take the bottom and flip it over. Now, what I usually recommend here, kids, is look back and see what your sign is going to be first. A negative times a negative is going to be a positive, so I'm not worried about those anymore. I also have a 2 on the top and a 2 on the bottom. So the negatives cancel out, the 2's cancel out, and where this root 3 is going to matter how much you're going to have to clean up. Since the root 3 is on the top, it's all right. I don't have to clean that up anymore because it's over 1, and dividing anything by 1 leaves it the same. Okay, the next section is trying to figure these out. You're trying to now find the angle. So what I've done here is I've told you what the answer is, kind of like up here we got these answers. You're trying to tell me what was the angle that you would need to get that answer. Now notice it says for all solutions, there's almost always going to be 2. There's a couple situations where there's only 1 solution, and you have to write your answer in radians, so no degrees. So the way we did this, we started off by making the coordinate plane. And if you want to draw the actual unit circle, you can. I'm not gonna. Okay, sine equals negative square root 2 over 2. I'm going to start with the negative part. Sine is negative here and here. Because sine is the same as the y-axis. The y-axis points downward into these 2 sections. So those 2 I'm going to check mark. Now the other way you could do this is look at your unit circle. Where is sine negative? Sine has a negative in these 2 quadrants. Sine has a positive in these 2 quadrants. So I check marked these 2. That means that my triangles are going to live down here. Now I got to figure out which triangle gives me an answer when I do the sine. Which one gives me an answer of square root 2 over 2? Well, this one's pretty obvious because the only triangle that has square root 2 over 2 is the 45. But you're looking at this side. Because sine is the y side, so that's the side that I'm looking for. Anyway, it's a 45. So now I'm going to put these 2 things together. The 45-degree angles, so in these 2 quadrants is where I was checked. My 45s in those 2 angles are in those 2 quadrants are these 2. So my answer would be 5 pi over 4 or 7 pi over 4. Theta equals 5 pi over 4 or 7 pi over 4. Here we go again. This time sine equals a positive number, so check, check. Again, I'm encouraging you to pause and try to do this on your own. But if you're stumped, then you want to follow along. Sine equals square root 3 over 2, so that means the y side of my triangle is square root 3 over 2. These are the y sides. They go up and down. And the triangle that has a y side of square root 3 over 2 is the 60. I'm going to write 60 down here. And now I'm going to put these 2 things together. Who are the 60? I'm in this quadrant and this quadrant. Who are the 60s? That's a 60 and that's a 60. So my answer is pi over 3 or 2 pi over 3. Sine of theta equals 1. Sine is positive. Check, check. Sine is 1. Ooh, we got a problem now because the y sides of these triangles, none of them are 1. Now the hypotenuse is 1, but that's not what we're talking about here. We're talking about the y sides. But if you think about it, look at the 2 check marks. In these 2 check marks, there is a place that has a y value of 1, and it's that spot up there. So instead of doing those check marks, sometimes it's easier to just put a dot on where you're going to be. And so theta would be equal to pi over 2. This is one of those examples where there is only one answer. There's only one place that has a y value of 1. This has a y value of 0. That has a y value of 0. This has a y value of -1. So that's the only solution. There isn't a mirror for that one. Tangent, same thing. Tangent is positive. Check, check. Now there is a long way to do this, but we made a little note to ourselves on the unit circle how to save us some time. So tangent is square root 3 over 3. We wrote what the tangents were for each one of these. So the tangent, we wanted the tangent to be square root 3 over 3, so that goes with the 30 triangle. So my answer would be the 30s in these 2 sections, so theta equals pi over 6 or 7 pi over 6. Oops. 7 pi over 6. And we just keep going. Same thing. This time we're talking cosines. Cosine is a negative. Cosine is negative there and there. Check, check. Cosine is x. So in the coordinate plane, x is negative on this side. So the cosine and the cosine would be negative in those two quadrants. Cosine is square root 2 over 2. That means I'm looking at the x side of this triangle. So the x sides go left and right. That one has a square root 2, so that's the one we want. The 45 in those sections are 3 pi over 4 or 5 pi over 4. Pause, try to do the next one. Cosine is positive, check, check. Cosine is square root 3 over 2. That means the x side. Be careful, there's two triangles that have square root 3 over 2s. So you have to know if you're talking cosines or if you're talking sines. We're talking cosines, that's x, that's left to right. So that would be the 30. Theta equals pi over 6 or 11 pi over 6. Cosine is -1. Cosine is negative, check, check. I look at my triangles. None of them have an x side of -1. So that usually means that there's another place over here. And if I look, these two quadrants, yep, it's going to be out there, -1. This is the only place where cosine is -1 at pi. Tangent of theta equals a positive. Check, check. Tangent equals square root 3. Look back at my triangles. Tangent equals square root 3. That's for a 60. So the 60s in those sections are pi over 3 or that'd be 4 pi over 3. Okay, so that's the sort of evaluating and solving trig equation stuff. Now we get on to some more about the graphing. So we're talking about a periodic function. It just means a function that repeats. And so the question basically is, how far do you go before you start to repeat? Now you could pick any place to start. I prefer to start at 0 and then just highlight until things start to repeat. So that's new. Then I go up, that's new. I go downward, that's new. I go up again because you had to go flat and then up. So this is considered new. Downward considered new. And then I go flat and then up. Nope, that's the end. So this is the end. I want to now figure out how far apart these things are. It goes from 0 until 2.5. This is halfway between 2 pi and 3 pi. So this would be 2.5 pi. That's a gap of 2.5 pi. That means my answer is 2.5 pi. Now look, you don't have to start at 0. You can start anywhere you want. You just got to make sure that you subtract where you end from where you began. I'm going to choose this one. I'm going to start here just to show you what I'm talking about. So going downward, new, and then up a little bit is new, then downward is new, and then up a little bit, and then after that it starts to repeat. So you got to be careful here. You ended at 5, you started at 1, so 5 take away 1 is 4. And then down here, you could pick anywhere that you want to start. I'm going to choose to start here this time, just because I want to. I'm the boss of me. I could go forward, and then I go up. That's new. That's new. All the way downward is new. Forward again, and up, and then it starts to repeat. So we started at 2 pi. We ended at 4 pi. That's a gap of 2 pi's. 4 pi, take away 2 pi would be 2 pi. Now we've got this stuff on the back of our unit circle. So you don't have to memorize all these things. You do have to know how to use them though. So it's talking about the amplitude, the period, and the midline. The midline is usually what you want to find first. It's halfway between the max and the min of the graph. So here's the maximum. There's the minimum. What I usually do is I just count blocks and then I go back and I worry about what they're counting by after. So this is a gap of 1, 2, 3, 4, 5, 6, 7, 8. So the middle would be 4. So I'm going to go back now 1, 2, 3, 4. There's my midline. The midline hits at a height of negative 1.5 on the y-axis. So we call this y equals negative 1.5. The amplitude is how far it is from the crest to the midline. So from the lowest, the highest or the lowest, doesn't really matter, to the midline. Now you do have to pay attention to what they're counting by. So we counted by 4, we said 1, 2, 3, 4, but this is actually going up by 0.5s each time. So it goes from negative 0.5 to 1, negative 1 to negative 0.5 to 0 to 0.5. That's a total distance of 2. So my amplitude would be 2. And then the period is the distance between two, well, it doesn't have to be crest, but in this case, I'm going to use a crest. So it starts at 0, it ends at 0.5, so this is a gap of 0.5. So my period would be 0.5. Identify the amplitude and the period of the given function where x is measured in degrees. All right, so again, this is not something you have to memorize. You do have to know how to look it up, though. So the amplitude is coming from whatever number is out front. Now, it's not just whatever number is out front. It's the absolute value of that. So you got to be a little bit careful. It's the absolute value of the number out front. It's the absolute value of the number out front. So the absolute value of 5, negative 5, I'm sorry, would be 5. The absolute value of 1/2 would be 1/2. The period is calculated by doing 360 divided by b. B is this number that's in front of the variable, whatever's connected to the variable. Sometimes it's an x, sometimes it's a theta. So we would do 360 divided by this thing right here is b. This thing right there is b, the thing connected to the variable. So I divide by 3. 360 divided by 3 would end up being 120. So my period would be 120 degrees. Again, to calculate the period, it's 360 divided by whatever b is. So this 3/4. Now, in a perfect world, you would flip and multiply and cancel. If not, though, you get to use your calculator. I know most of you would probably do it this way. 360 divided by, and then I'm going to make another fraction on the bottom, 3/4, and we get 480. I don't know if you guys can you guys see that? Yeah. That made it worse. There it is, 360 divided by 3/4. So I made a fraction, 360, and then moved to the bottom and made another fraction, 3/4. You could also do 360 and then 3 divided by 4 on the bottom. It's going to give you the same answer either way. So amplitude again, super easy to figure out. It's the A value, absolute valued. So in this case, A is 2. Sorry, A is the absolute value of 2, which is 2. Absolute value of negative 5, which is 5. And then we also have something called a phase shift. The phase shift is the horizontal translation. The phase shift is this thing that's added or subtracted onto the variable, but remember, it does the opposite of what you would think. So this right here, this is the phase shift. It does the opposite of what you would think it says. This here is the phase shift. This is the vertical shift. And it does the same. But the phase shift is only worried about the one that, this should say same, the one that's going in the x direction. These are going in the y direction. Okay, so this says x plus 45, so that means that we're going to move 45 left. If you wrote negative 45 there, that'd be okay as well. So connected to x is negative 60, so I do the opposite of that, so that would be 60 degrees to the right. If you just wrote 60 there, I'd still give you full credit. Okay, and so now we're going to put all those ideas together based off of this graph. So I gave you the original. So write an equation for the solid line graph using sine. They have to tell you what the function is. So if they don't tell you this, you wouldn't be able to do it because depending on if the original is sine or cosine, it could be shifted. Anyway, they'll tell you what to use. So what I had here is this is the original sine graph. See how it goes a height of 1. It's got a period of 360. And then we took that graph and we did something to it. We changed it. We transformed it, we call it. So I gave you some options here. You don't have to fill these in, but they make the next part a lot easier if you fill all this stuff in. So the amplitude, you got to first find the midline to find the amplitude. So I'm going to go from the top to the bottom, the max to the min. That's a gap of 1, 2, 3, 4, 5, 6. So 1, 2, 3. Here's the midline. So the midline to the crest, it's counting by 1, so that would be a 3. So my amplitude is 3. The period is how far for one cycle. I picked 2 troughs. Now, in this case, it's not a nice number, so you're going to have to do your calc. You're going to have to figure this out. This is at 225 is where you ended, and then you take away where you began, which is negative 135. I grab my calc now. Ends up as 360. That's good news. That makes life a lot easier when your period is 360 degrees. Basically, it means you don't have any horizontal transformation. The shift is what happens to the midline. So if you look, here's the parent function. The phase shift is, oh, sorry. The phase shift is not that. I had that wrong. The phase shift is how much the crests get moved. So here's the original, and it goes backwards. This is where the original crest is. This is where the new crest is. So we move to the left 45 degrees. If I move to the left 45 degrees, my phase shift is negative 45. So the phase shift is how far you get moved left to right. The vertical shift is what I had wrong. That's where the midline gets moved. This midline is supposed to be at a height of 0. It said it's at a height of 1. So we had a shift up 1. So my vertical shift would be 1. Now, what I'm doing here is I'm just plugging and chugging into all this stuff. A is the amplitude, B is the period, and these are my 2 shifts. This is the phase shift, X. This is the vertical shift, Y. So Y equals, I've got an amplitude of 3 that goes out in front. I know my function is sine. Like I said, if your phase shift, if your period is 360, you don't have to do anything there. And then X opposite, and then same at the end. So there would be the equation that would get me this solid line graph. All right, I'm going to encourage you to pause and try to do this on your own, and then come back. So again, we've got sine. I've got to figure out where my midline is. So there's the max, there's the min, there gap 1, 2, 3, 4. So this is going to -2 is going to be the middle. I've got an amplitude of 2. I've got a period of, okay, so that ended at 135. Subtract -225, that's going to be 360 again. Which is good news, which means basically you don't even have to worry about this. Because it's supposed to rotate 360, and ours did rotate 360. Phase shift is the X shift. So I'm going to go from this low point. I'm going to do low points this time. Low point to this one. How did it get moved? It got forward. It got moved forward. It went from -90 to -45. So that means it went right 45 degrees. You always go from the original to the new one. The original is the dashed one. That's the parent function. The solid is the new. So we got moved right 45 degrees. So my phase shift is 45 degrees. And then it looks like our midline got moved down 2. So my vertical shift would be -2. And so we put this all together. Y equals my amplitude. Again, I'm just using this. It's amplitude. Now this might say cosine, guys. If it's a cosine function, this can change. It doesn't have to be sine. This is your period, but 360 divided by 360 is 1, so we don't care about that in our situation. So this is sine of 360 divided by 360 is 1 out in front. X, and then does the opposite, and then the same. All right, so good luck. If you have any more questions, ask me in class.